Okay, so we have made it to section 8.6. The one that you looked at and went, oh no, but you wondered, could I do this now? So when you're doing these problems, and these are some of the simple ones, I'm trying to teach you some things ahead of time. Mostly it's just adding and subtracting until you get to the very last part. So as long as you're good with the adding and subtracting, that'll be fine. But you also got to have the multiplication and division. You got to keep all these rules in your head. You got to balance them all the time. So here is just a subtraction problem. But remember, in order to subtract, we have to have a common denominator. In this case, our common denominator is going to be z. So when I write this as our common denominator, over here we have 2z over 1 originally, which means I need to multiply my top by z. So that's going to give me 2z squared minus, just like we did in the last one, I want to try to keep it all in 1. So on the bottom, my common denominator was z. That's what it's going to end up being. And since I'm putting everything on the top together, I've got my minus z. And then remember that you have to distribute it, so it's a minus 1. Now the question is, can I factor anything out such that it will cancel? And when I go to factor out the top, I might get something, but it's not going to be just a z, which is all I had on the bottom. It's going to be like a z plus 1 or a z minus 1, and that's not going to cancel out. So that's my answer. Down here, when you have something that doesn't have a fraction to it, but you know you're going to need a fraction, go ahead and stick a 1 underneath. So now my LCD is v plus 3. So this one doesn't need anything, but this one will. It's going to need to be multiplied by v plus 3. So that means that my bottom is going to end up being v plus 3. But my top we're going to have to talk about. So I've got my 3v minus 1 here. 3v minus 1. Then minus whatever we get here when I multiply. V times v is v squared, so that'll be minus v squared. And then minus 3v. Rearranging that, we end up with negative v squared. 3v minus 3v will cancel out. And then minus 1. Over my v plus 3. Now, can this factor? Well, before we send it to factor, we'd have to take out that negative, right? So if I take out the negative, that flips my numbers. So I'm left with 1 minus v squared over v plus 3, which it's true that this will rearrange, and I can get a 1 minus v and a 1 plus v if I factored it, with the negative still out front. But none of that cancels with anything down here. So the factoring didn't really help me out. So if it doesn't help me out, there's really no need to worry about doing it. And remember, your negative can be up top, out front, or in the bottom. Doesn't matter where it is. Or they could not have it at all. They could have left it like this over here, because pulling out the negative didn't help. But either one's fine. I know what it is. Now, we've talked about some of the preliminary stuff. Let's get to a real problem. going to do number 14. 1 over r plus 1 over s over 3 over 5r plus 3 over 5s. I know you notice that's the same problem. There's a reason for that. I'm curious as to which way you're going to want to go with it, because there are two different ways to solve it. So I'm going to show you both, and then I'm going to let you pick, and that's the one you need to go with all the time. So the first way is to do it exactly like you see it. Do the problem on top as its own problem, and do the problem on the bottom as its own problem. Then deal with the fact that what you're really looking at is a division problem. So that's what I'm going to do with this one, and then I'll show you one over there, and you can tell me which way you like best. So right here up top, my common denominator is going to be RS. So that means I'm going to end up with an RS. And then since that's going to be RS, this one needs an S, and this one needs an R. So on top, I end up with S plus R. On the bottom, my LCD is 5RS, because they both have a 5. And this one has an R, and that one has an S, so it's 5RS, because everything has to be in there. Over here, we're missing an S, and over here, we're missing an R. So my bottom is 5RS. Over here, I have 3S on top, plus 3R. Then, since that's really a division problem, this divided by that, that's what I'm going to write it like. S plus R over RS divided by 3S plus 3R over 5RS. Only when we have a division problem, we learn that you really flip it over and multiply. So that's like S plus R over RS times 5RS over 3S plus 3R. We were told to make sure everything is factored. So if I factor this, I get a 3 times S plus R. And then you cross cancel if you can. Something on top with something on the bottom. Well, my R's will cancel out. My S's cancel out. And my S plus R cancels out. Leaves me with 5 over 3. And we're done. So it was 2 addition problems and 1 division problem, which turned into a multiplication problem. It's all right. It's all good. That's one way of doing it. That's usually the way I teach, by the way, because you know all those things. But I have a friend who uses her spray. She calls it a spray. I don't know how to make it up. She does. So she would say, when you find the LCD, you don't want just the LCD of the top or just the LCD of the bottom like I did over here. You want the LCD of all the bottoms. So this LCD was RS. This LCD is 5RS, which means 5RS is what we'd have to use for everything because it's what works for all of them. It's the common denominator of every single one of those. If we go ahead and make that our common denominator, Then on top, I would have the 5RS. And that's going to give me that it's missing a 5S and that this is missing a 5R. So I have 5S plus 5R. On the bottom, we still have our 5RS. Up here, this is still missing the S, and this is still missing the R. That'll give me 3S plus 3R. Only now that we see that these are exactly the same, that means that when I go through the trouble of flipping it over and multiplying, they're going to cancel each other out. So we don't even show that anymore. It's just gone. Which leaves us with 5S plus 5R over 3S plus 3R. Because if you've done it right, they'll always be the same, and they'll always cancel each other out. Because whenever you flip it over and multiply, you'd have the same thing on top that you'd end up having on the bottom. Now I need to factor it. And you see that my S plus R's cancel out, and you're left with 5 over 3. Now, it doesn't matter which way you do this problem. You can do it this way, or you can do it that way. Either way, it's going to work out. And why does she call it spray? Because in her mind, she sprays that LCD everywhere to all of her denominators. That's why she calls it spray. I'm just telling you what she does. She sprays it over the whole thing. That's what she does in class. I can't help it. I observed her. That's what she did. Just tell you what she does. Let's have you try one. A really, really hard one. Because I think you can do a really, really hard one. Number 22. Wish I knew which way you'd pick, so I knew which way I should show you how to do it. Kind of stinky. Go ahead and try it. I'll be erasing this. Well, you're not done yet? Pause it until you finish. Okay. I'm guessing you chose the spray. It's just a hunch. First of all, I finish out my fractions so you can see that they're fractions. But the common denominator is the same on top as it is on the bottom, so whether you chose the spray or not, it's going to end up working. You get the LCD is equal to C plus 5 on top and on bottom. Like I said, it's going to work either way. So C plus 5. The thing keeping this from having a C plus 5 on the bottom is C plus 5. So that's going to give me 5C plus 25 minus 25, because it doesn't need anything, over this side is missing a C plus 5 too. Which is going to give me a 3C plus 15 minus a 15. Now, I know you caught this, right? 25s cancel out, 15s cancel each other out, which leaves you with 5C over, that's not a C, C plus 5 over 3C over C plus 5. And like I said before, Even without having to do the rewriting and the flipping over, you can see that these are exactly the same. So they're going to cancel out. And you end up with 5c over 3c. The c's can cancel each other out, and you're left with 5 over 3. Again, we didn't plan that. I wouldn't have wanted it to come out the same anyway. Obviously not planned. One more. Super hard one. Okay, not really super hard. One more moderately hard one. I didn't give you a super hard one. Moderately hard one. Kind of, sort of, a little bit hard. Not really. Just long. Maybe kind of. Number 30. Y plus 3 minus 1 over y plus 3. There are two ways you could look at this. You could look at this as y over 1 plus 3 over 1. Or you could look at it as y plus 3 over 1, which is how I'm choosing to look at it. Because that keeps me from doing a whole bunch of stuff I don't need to do. So what's my common denominator? Y plus 3. So that's what I need to multiply my top by. This one gets multiplied by nothing because we already have y plus 3 down there. So that's y squared plus 3y plus 3y is plus 6y plus 9 over y plus 3 minus 1 over y plus 3. Which gives us y squared plus 6y plus 8 over y plus 3. Can we factor the top? Yes, you can. It's going to end up being y plus 2 times y plus 4. Does that help us cancel anything? No, it doesn't. So since it doesn't, there's no need in us worrying about it. That's your answer. See, they don't all end up being 5 plus 3. Just some of them. Not even all of some of them, just some of them. Classwork. Oh, page would be good. Page 339. Numbers 3, 7, 13, 17, and 23. Lots of practice. Homework. Numbers 9, 15, 19, 25, and 29. Okay, so I know you. I'm sorry that I know you so well, but I do. I do know you. You're going to like this section. Unfortunately, you're going to like it a lot. And you're going to think to yourself, ooh, let's do another one. I know it's going to happen. I really do. So I'm going to tell you that if you really want to, not that you have to, not that I'm even going to ask about it, but if you really want to, you can always work all the odd problems up through number 45 and see that you're getting them right. Just saying. It's great practice for your quiz, by the way, which is getting ready to happen like really soon. Okay, it happens next. So tomorrow or the next day you have math. That's when you're going to take your quiz. Your quiz covers section 8.1, 8.2, 8.3, 8.4, and 8.5, and 8.6. They're all in there. So there's not very much from section 1 in there because you do so much of section 1 and all the other sections. There's some of section 2, some of section 3, some of section 4, some of section 5, and section 6. There's a problem like this in there. But you need to understand that if you can do section 6, then you're really practicing sections 1, 2, 3, 4, and 5. So if you got section 6, I'm saying you're probably ready for the quiz. So that's why I said if you want to do some extra stuff, just for the heck of it, then this section up through the odd problems, very challenging, don't get me wrong. 45 is challenging, not more challenging than I'm sure you can handle. But they're challenging, don't get me wrong. They are challenging, but they're not overly challenging. So I think you could accomplish them. Make sure you do the odd, make sure you can look in the back of the book, make sure you're getting them right. I'm just saying, they're there for you. Okay. We are not going to do section 8.7. We're skipping that because it's really algebra 2, and that's the way I'm going to teach it. Section 8.8 we will do. It'll happen. See, there's your stuff. And then section 8.9 we will do. That's when I get to show you a trick. I like my trick. Then we'll do a little bit of 8.10, and I'll go ahead and squeeze a little bit of 8.4 and a little bit of, 10.4 and 10.5 into it before you take your test. So, yeah, be ready for all that. I think the test, sorry, the camera adjusted. I think the test is going to take you maybe a week longer before you actually get to the test. So, anyway. Do with it what you will. See you next time. Bye.